Welcome back, my fellow duplicants, to Oxygen Not Included. I've been messing around with the automation system here last night, and I've come up with something that I would like to share with you. One is this switching unit right here. So this, what essentially is happening here is that this switch is just like the light switch on your door, right? So except for you can turn it on and off with a signal, as opposed to one of these switches, which is basically just on or off, right? But it takes a duplicate. This one takes a signal to turn on or off. So let me show you what this is doing here, and then I'll kind of show you a system that we can run here based on the smarts that you can pump into this system. So what this is, if I just kind of deconstruct some of this stuff just to kind of simplify it. Okay, so here's a good example of what this is doing. So you can see here I have this setup, and what it is two little miniature gas pumps, and it's pumping air from one side to the other side, and that's turning on and off the Atmos sensor on one side or the other. And then I have an AND gate up here at the top, so if a signal runs inside of here, it can then say, well, I'm going to turn this pump on, and it'll switch to the other side, enabling this one to run. So if I just turn this on for a little bit, you can see here now the gas pump is turning on. It pumped a little bit of gas over here until it dropped beneath that, because it takes both of these to be green in order for this to turn on. And that flipped the door. So this door closed and that door opened, and it will stay this way continuously. It won't ever switch back and forth, and you don't need to manually switch it. All you need to do is send yet another signal to this side. So maybe this turns on and we've turned this one off, whatever that is, and it will now flip to the other side and maintain that position. Now, getting this to work and work right was a little bit of a trick, so let me show you some of the things and some of the bugs that I ran into with it. So the first thing we need to understand here is how much air is in these chambers, and what we want to do is balance the air between the two sides. I'm figuring that you'll pretty much do this on construction, and whatever that number is you end up with here, you're going to set the above to be just above how much air you have in the entire system. So I would build this whole thing right here, and then build the centerpieces and cap it off so that it's a sealed system. And that should work just fine. You can use mini gas pumps, you can also use the larger gas pumps as well. Looking at the gas overlay though, we can see the pipes. Now, it would be better if I could flip one of these pumps, but the thing is the automation block doesn't actually move when the pump flips upside down. I'm sure that'll be fixed at some point. But having the same length between these pipes is kind of important. And I did do it with 3 chunks right next to each other. However, when I did 3 gas pipes, and then I threw the sensor right next to that, there was a chance that the overpressure that was coming out of these vents would cause this signal to spike up before the chamber balanced. So having the sensor down here on the other side of the pump, so that it's a little bit farther away, allows that chamber to balance out before that switch clicks over. So that way you don't end up in a situation where both of these are green, allowing both equipment, whatever it is you're trying to synchronize, to be going at the same time, because that wouldn't really be good. As far as the automation overlay, you kind of already saw it right here. It's just 2 AND sort of wires up there. So if this is green and that is green, then the pump will turn on and it'll flip to the other side. How you'll know that this is set up right is that if both of your input signals are green, then this thing should continuously flip from side to side as it's balancing out, because you're pumping a little bit more air through thanks to the length of the pipe, right? Now, I tried to do this with liquid and using the little switch down there, but right now that switch doesn't seem to activate when at least I put water on top of it. So a pump would work, and it would probably be a little bit more efficient because you don't have to pump quite as many tiles and you can work with less fluid. However, right now, from what I can see, this pressure plate is not working with a liquid. So now that we have this simple machine up and running, we can use it to power some really cool stuff that has multiple stages with it that, where equipment needs to run and run until another condition is met. Essentially, that's what I'm talking about. And the reason I was building this is because I've always wanted to build a gas compressor, and a real one, not necessarily just using pumps to pump it in to a certain amount of pressure and then into a liquid puddle or whatever. I really wanted to just make a real gas compressor that works with cylinders, and that's essentially what this is right here. So let me plug it up and get it working for you. Alright, so what do I have going on here? Well, this is a gas compressor. So as we can see here, this signal over here is above pressure, so therefore it's sending a active signal to this liquid pump. So this liquid pump is running and it's moving all of its volume over here to the right chamber. This right chamber is sealed so that it's compressing the gas. And now once that gas goes all the way up here to the top and this switch sends, then that will then flip our switch back on over to the other side, turning this pump off, turning that pump on, and also activating some doors in the process to allow the gas pressure in here to move on over into this space, closing the door before it loses that pressure. So I'll just speed it up so we can actually see it work, because seeing it work is a lot easier than me just telling you. So this is naphtha right here because it builds vertically and it doesn't flow to the side. It's still that way in this current build of the game. And as we can see here, we're reaching up here near the top, and this hydro sensor will go over 500 kilograms, and we've opened up this mechanized door to allow a little bit more oxygen into this space right here. And now we're pumping that naphtha back to the other side. Okay, so the liquid is just finishing up moving from the right chamber to the left chamber, and that should send this signal here as active, causing this to flip, right? So here we go. Should be above, oops, that has to be 560 kilograms is the condition and it must meet. And there we go. So now this door opens because I've tied it in as well, and I'm using a buffer gate over here. That allows you an automation delay. So once this goes from active to inactive, or from green to red, it will maintain whatever signal that's running through it for a predetermined amount of time. In this case, I'm going to say, if I can edit it, I'm going to say 30 seconds because I don't want that door to close too soon. I want to let the oxygen flow from this space over here into this chamber so that we can charge it up. So these are your valves, and then this is our piston that's moving up, but this is working in the function of a gas compressor, right? So we open the valve, bring the gas in, compress it, open the other valve, let it go out into the other chamber, and then run that cycle back and forth. Now this doesn't take any intervention as far as duplicates are concerned because it's just an automated system that's going back and forth. This switch setup right here is useful for a lot more practical things rather than a gas compressor. One of them being, moving gas into a chamber and then cooling it or processing it, cleaning it, heating it, whatever you need to do to that, and then moving it on from there, so that the signal's kind of maintained and you can let a pump run until a temperature is met and then run something different. So one of the things that we've wanted to do for a long time here is to use doors to control like liquids or gases. In this case, for like a cooling solution, you have this cold water, everything reaches the temperature, you dump a bunch of water across it, sort of thing. And that's kind of what we're talking about right here. And there's a lot of really fun ideas that you can do with just that sort of thing right there. So Samuel was talking about that, and there's a couple other people that were talking about that as well. And yeah, that's exactly what we're doing right here, but we're using it to compress gas. So what I want to do here is try to optimize this system a little bit, just for the sake of it, because it's interesting, and see what all we can do, and maybe optimize it a little bit, because we should be able to run a liquid or drop liquid from above using a door, and then only have to run the pump in order to move it back up. So we can use gravity for 50% of the energy that we need. Oh, I don't know where anybody posted this one right here. I just found the comment and I kind of lost it. This is the gas chamber for naughty duplicates. People are horrible. My gosh. That's how we could have done in Travoldo the Undertaker, though. That is truly terrible. There was another question here of whether or not this will end my Mega Base challenge. And you know what? I don't think it will. But let's load up the other base just to see if it would actually work. It's a good question for those of us that are actually playing the other version of the game. It looks like it loaded alright. Nothing blew up. The exosuits are still filling with oxygen. Coal generator is still running. Hydrogen generator is still operating. Natural gas is still pumping all sorts of craziness. Looks like we're in good shape and we'll be able to just modify the Mega Base to accept automation. A lot of really good ideas right around this thing. Okay, so let me just mop this stuff up. We don't need this anymore. And we're just going to deconstruct everything and start over. So I'm going to use the new metal tiles, and we're going to make a tungsten water tank down here. Now let's try this number. We have a mechanized door, but we're going to put it on its side like that. And then this is going to be the valve that lets the compressed gas out. This will be the one that lets it in. And I'm going to create a chamber over here that's going to pre-charge the gas. So we're going to use an air pump to put in 20 kilograms worth of oxygen right here. And then we're going to try to take it above 20 kilograms over on this side. I'm going to make this liquid chamber a little bit smaller so that we can actually let it move a little bit more. So this is 1, 2, 3, 1, 2, 3, 4. Okay. All right, so I need a liquid pump down here at the bottom, and then I'm going to put naphtha up on top of this. So that's going to be, you know, I want to maintain at least one tile though for gas. So the trick is to get 3 tall here and then 4 tall over here. So when we get the gas inside of this chamber here, we have our gas is located right in this spot, so it can just go right over there without coming back. Okay, so boom, just like that. So I've got a bunch of the liquid up there. If I open this, it should dump down. Let's see what happens if I run a signal to that. So it's locked, and then I open it, and then I close it. So the oxygen did move, but I still have some oxygen at the top. So now I need to pump this up, but I want to stop the pumping in this location here, and then I want this one to keep going until it runs out so that the volume separates and I have that empty space right there. So for that, I think what I want to do is use one of those valves, right? So that's a liquid shutoff valve. So I could put that liquid shutoff valve right there. So it will run up to that, and then I will have a liquid vent right there. And then I'll also have a power switch right next to it, right? So this will be my hydro switch. I really need that hydro switch like right there. So that's one vent, and then I have the other vent. So we can separate this 50-50 as it's initially pumping. Nope, don't do that. And then to test this guy, no, we could just do this, right? So once this goes above, how much do I have right there? Let's say 250 kilograms. It will, I want that to be the opposite. As long as it's below 250 kilograms, it's on. So now the liquid can move up through there. What? Or not? Does it take power? It does. Okay, so that just became inactive, and now all the liquid's pumping into the left location there. So long as I don't end up with too much, it should be just fine. Aha! Bingo! That worked out. So now when I open this door, boop, goes right back down, and it starts pumping back up. All right, I think that's gonna work. So now I need to fill the chamber over here on the left. We'll just use a gas pump, very simple, maybe even a couple gas pumps. And we'll just pipe that in. And we'll use a couple of high pressure gas vents right there. Look at all that oxygen in that space there. Boom! So that'll go up to 20 kilograms, and then it'll be full. So if I send an automation signal at this point, just kind of manually run this through its paces, that should allow all of this oxygen over here to fill in for this space. So I'm just going to turn it on and off real quick. Oops, I need to have it on a little bit longer, right? So there we go. We got 12.3 kilograms of oxygen inside of here. We'll run another signal to this door. Oops. It moved over. That's not what I wanted. Well, this works out fine. I have 10 kilograms of oxygen right here in the middle. Let's dump some liquid on it. And now I have 38 kilograms of oxygen right there before it pumps away. I want to open this door. And I have moved a little bit of oxygen. So it's 30 and then 10. That might work. All right, so now let's automate this. Okay, I'm going to use a hydro switch that lets me know that I've built up enough liquid to trip this sensor. And that'll be the signal I use in order to turn on this pump. It'll also be the same signal I use to open that door. Let's see if I can figure this one out. Okay, so if this is off, then I want that door. No, I want this pump to run. That's what I want. You know what? I need to move this liquid vent. That needs to be one lower than where it is. Okay, so just like this. And then I'm going to use a hydro switch above that because I need a signal that says this is full and we're ready to open up this door. So if this is above, let's say 65 kilograms, then that should be active. So that should be green. There we go. If that is green, then this door can open. Also, if both of those are open, then what I want to happen is... Oh no, not that. Anything but that. So now this condition over here is active, but I've met the circumstance to flip the thing to the other side. So this will open up the door, and this pump will now flip the switch to the other side. Dink. So we're moving on to the next phase, right? So we've opened the door, we let in some oxygen, as we can see right here. And all madness is happening. So let's send back the other signal in order to cycle it back. So if this condition is met and we're in that cycle right here where this door is open, then we want to flip it back and pump the liquid back up to the top. Alright, here we go. Well, it keeps working, but I don't think I have the arrangement correct for this kind of setup. What I think I want to have is this mechanized airlock up here at the top, because what I'm seeing is that when I drop this liquid, that gas, you know, surprisingly to me, actually finds its way to the top very, very quickly without much hassle. So at that point, I can open up that door at the top, let it out before I drop this door next time. You know, so having it over here to the right really doesn't make any sense with a gravity pump system. Okay, so what is the absolute thing that has to work here, right? So while this pump is pumping its liquid to the top, this door needs to be closed. So those are the two ones that are hooked up to the switches over here. If this pump up top reaches a liquid pressure, telling me that I've pumped all the liquid out of this space down here up to the top, I'm going to send both an active signal here and an active signal here, flipping the switch. Who is suffocating? Ah, no more oxygen. Crap. How did not Harold die? Dude, I just gave you tons of oxygen. Oh, man. It's alright. We'll put him in a petroleum casket. Rest in peace, Not Harold. Thank you for all of your good experiments and running on the manual generator. Oh, that means I need another one. Okay, so while this here is also going to be active, I want this gate up top to open up, which means I don't necessarily want both of these to open at the exact same time. So what I really want to do is add a filter gate that'll allow this to stay inactive for a predetermined amount of time while I'm flushing that oxygen out the top. Or gas, whatever gas we're putting in there, right? 5 seconds should be plenty. Seems like they have a little bug with that resetting anyhow. What the heck? Starved to death? No, Lindsay! Forgot about the food. Welcome to the petroleum casket. I'm so focused on my automation that I forgot to give them more food. Alright, so let's see if this works. We let the vacuum out. We let some of the oxygen in. And it's flowing into this space. And what condition am I not meeting? Aha! I have not hooked up the return signal here that says that we can now start pumping the liquid back. So there we go. And now it's going to pump liquid up here, compressing this gas. Adding a delay to this is actually not a bad idea because it allows the gas pumps to force more oxygen into this space. Cool. This might actually work out pretty good. Now, wait a minute. Oh! Okay, so now I can see I have 80 kilograms worth of oxygen right here. Let's just slow it down a little bit. We're pumping out the last of the naphtha down here. So that is now ending, which means that we should overcome the amount of pressure inside of here, allowing this door to open. Looks like 210 is going to be the right number. There we go. We let that oxygen out. You can see we're now up to 30 kilograms up there. Okay, so here's an interesting thing. Once this door opened, this door should close. You know, before the liquid drops away from this, because otherwise it's going to pull some of that oxygen out of that space. So what can I use up there? So what I can do here is that if one of these is active, then this door will be open. However, if they're both active, then it's going to be closed. Or did I just make the same thing? Ah! You know what? I think I'm trying to make it a little bit too complex here. Let's just leave it like that, and it should work just fine. I mean, I don't really know the practical use of this anyhow, besides trying to maybe take some sort of gas and super compress it into an area, which I guess could be useful. And I'm sure there's better ways of doing this, but it might take a fair bit of experimentation before we get it right. So the question is, how much oxygen is up here? Right now, it's 23.2 kilograms. If we can get this up to a very, very high pressure, then I think we've done something correct. Maybe. Let's see what happens. There we go. So now I've got 41 up there. I guess that just happens fast enough to where it doesn't really matter. It's just trying to overcomplicate it. Never done that in my life. I always make things simple, don't I? So there we go, a little bit more gas in there. It did drop a few kilograms, but it still maintains it quite well. If we were to actually make this taller, it would let more of that oxygen through and actually less of it out. Maybe or not. I would think it would. But right now, it looks like it's working. That isn't half bad. Now, I suppose one thing I could do down here, since I am using the naphtha right there, is that I don't necessarily need gas pumps here. I could just let this flow in from like a geyser or something like that and save a bunch of energy. But right now, this is a pretty quick way to, pump that gas up, I guess. I don't know if it's really that quick, but it's a method. Ha! Boom! It works! Look at that. 85 kilograms of oxygen right up there. This machine is slowly working to kill all of you guys. For Devin, whatever reason I cannot rename you. Devin the Unnameable. Oh well. So there you have it, guys. I was able to create a super gas compressor. I don't really know if it has any real practical use, but we were also introduced to the whole switch thing and kind of keeping one thing active until a signal and flip it to the other side. So that's pretty cool, and I'm sure there's really some creative things that we could potentially come up with, once we start stringing some of this stuff together, a whole logic table of things, right? Ooh, it'll be awesome. Thanks for watching, guys. Hopefully you guys have enjoyed this little episode of Oxygen Not Included. Let me know some of the crazy things that you guys have been designing with this new automation system down there in the comment section below. I'm looking forward to seeing them. Also looking forward to learning a little bit more about this stuff, because this isn't really my primary focus, but I'm learning some stuff, and it's cool to see that this game is becoming so educational in what it's actually doing. So that's absolutely awesome. If I've earned your subscription, then thank you so much for that. Have a great day, guys. Stay awesome. Peace. Brothgar out.